periodic pattern Laplace transform with this idea. Now we discuss last question. After that we again discuss the some properties. Question is xt is del at plus b. We want to calculate Laplace of it. For calculation of Laplace, put this into the formula, applying scaling property before formula application. B by a e power minus st dt. In this case of impulse is located at t plus b by a equals to 0. T equals to minus b by a. So we put directly into the expression and we get answer s b by a, which is positive for all s. Can be write as that is the final answer for. Now we discuss a question regarding Laplace. Gt is given to us in this way: xt plus alpha x of minus t, and xt is defined beta e power minus t ut, and Laplace of gt is gs s upon s square minus 1 determine the value of alpha and beta. Solution for this question is given to us gt is defined in this way, xt is defined in this way, gt Laplace is given to us. We have to compare. Laplace of s is beta upon s plus 1, and by taking Laplace of this equation, gs equals to xs plus alpha x of minus s. 1 plus alpha 1 plus, I'll remove this xs, put this value beta s plus 1 plus alpha 1 minus s beta. Now I compare with this component by taking LCM. Beta s plus 1 minus alpha beta s minus 1. By taking LCM, we get this result, and now we compare with given expression. By comparison we get these two values, alpha and beta. Minus 1 minus alpha equals to 0, alpha equals to minus 1, 2 beta equals to 1, beta equals to half. We get the result. Now discuss next property. Next property differentiation in time domain. GATE is an exam where we have we have to mug up some formulas, but it is not required. We have to stick on procedure. In other exam, formula is required. In GATE, lot of formula, lot of lot of practice is required other than formula. Logic should be applied. Concept should be clear. The difference between other exam and GATE is not so much formula is required. XT is XS. We want to differentiate XT in time domain. What will the result? S XS. We have to learn this. It is not required because we know a magical formula with us is it is it is a magical formula. If we differentiate this term, we get the result. How can we get? Simple procedure is that differentiation in time domain. If we differentiate this term, means we have two type of formula. We have two type of formulas. First is for Laplace transform, second is for inverse Laplace transform. We want to develop differentiation in time domain. If we want to develop differentiation in time domain, means we are differentiating this term. If we differentiate this term by considering dt is variable and remaining terms are constant. If remaining terms are constant, we can differentiate directly dxt upon dt. Directly we can conclude. How? This term, no t term, only constant. This term also, no t term, no variable of t, no component of t, only this term have t component. Differentiation of this term is e power st. While differentiating, single s come out. Complete term remains same, only single s is additional term, so we have to add s, remaining term are same. In this way we can derive another property also, differentiation in time domain, and move ahead. I repeat, xt equals to, this is the inverse formula. If I differentiate this term, means differentiation in this domain also. This term is constant, 1 upon j 2 pi constant from s complex to s. xs is a no element of t, does not depend on t. This term is also does not depend on t, only single term is depend on t. We have to differentiate this term and additional term added to the expression. Second property, in same manner, differentiation in s domain. S domain differentiation. First I write expression for S domain differentiation, minus t xt, Laplace transform of this is dxs upon ds. Our formula for Laplace is xs xt e power minus dt. If I want differentiation in this direction, means differentiation of this term also. This term differentiation means xt is not a function of s, it is constant. dt is also not function of s, it is constant. We can differentiate directly this term. E power minus st. If we differentiate this term, we get minus t come out with xt with the remaining term. So this modification required from previous case while differentiating in S domain. If this is true, in this way we we are not required to learn this expression. We can simply derive with some formula. Remaining are constants depend on particular term. This term come out a component, and this is the next property. Integration in time domain. Integration in time domain. If xt is xs as originally said, then integration in time domain is infinite to t x tau d tau equals to 1 upon s xs. We can also prove through integration. If we integrate this term, we have this result. How it is possible? By writing complete formula. Minus infinite to infinite e power minus st dt integration minus infinite to t integrating with this function. We have to use inverse formula. Once we are using inverse formula, we have to write down expression here. Sigma j omega sigma plus j omega xs e power st ds. Now integration limit minus infinite to t d tau. Now with the complete expression is t is converted into tau because function is defined in tau. With the complete expression, this is not function of t, this is not function of t, it is constant. Integrating term is only this one. We integrate this term and then apply it, we got the result. By integrating this term, we found integration of this term is tau upon s minus infinite to t. We put the value, this term is continue, put the value e power minus st minus 0 upon s. This term also required for this integration, then result is modified with only s term. In this way we got the result of integration. Next property integration in time domain. In time domain, as per property 1 upon t s to infinite xs ds. Now we are integrating in s domain. Integration in s domain. Now we are integrating in s domain, so we have to use this formula. Xs equals to basic Laplace integration, Laplace transform formula. Once I integrate from limit s to infinite ds, means I am integrating this term with respect to ds. This term is constant, no s term, this term is constant. I separate out these two terms, and remaining term from s to infinite e power minus st ds. This integration I solve separately, e power minus st upon minus s from s to infinite. By putting value, one term added in this is, sorry, by integrating I got, with respect to ds I got 1 upon t. By putting value I get result 1 upon, by putting value I get 1 upon t. This final answer for this is 1 upon t xt. Laplace transform is from s to infinite xs ds. This is our complete final answer. All the four property we can derive from integration and differentiation with desired formula. Move ahead. Now we discuss one particular type of problem, inverse Laplace transform by partial fraction. I took an example, very simple example, 4s plus 2s plus 4 s square plus 4s plus 3 by partial fraction. Partial factors. Applying these three conditions. ROC for first is greater than minus 1. ROC for second is less than minus 3. ROC for third case is vary between minus 3 to minus 1. How partial fraction can be performed? Partial fraction is very simple idea to calculate the inverse of Laplace transform. First, factorize the denominator of s square plus 4s plus 3. By factorization we get s plus 1 s plus 3, and then calculate the value of coefficient, factor coefficient a b s plus 3. For calculation of a we use this idea, 2s plus 4 upon s plus 3, s equals to minus 1. By putting this value we get the result 1. And for b calculation again same method is used, and put s equals to minus 3, we got the result plus 1. In both case we have coefficient 1 upon s plus 1 plus 1 upon s plus 3. We want to calculate inverse of it. Directly we can write expression for this, e power t e power minus 3t bracket ut. The complete expression for inverse as per ROC. If ROC come into the picture, this exercise we also done in maths circuit control, but consideration of ROC only in signal and system. First we consider ROC. We have final answer xs equals to 1 upon s plus 1, 1 upon s plus 3. If we consider ROC, this ROC is greater than particular value minus 1, then we can write expression as in previous case I already wrote xt. If I consider second ROC, which is less than minus 3, less than minus 3 means minus 3 less than. At this point we have to modify our answer accordingly. Now answer is e power minus t u of minus t minus e power minus 3t u of minus t, our answer. Why is it so? We have this function. Inverse of this is e power t ut minus. Same inverse of this function also minus. It depends on ROC where this xs is exist. If in the first case ROC is outer area greater than this pole, in the second case ROC is less than this pole, right half of the plane, right half of the plane. In condition for causal signal we use this idea, for anti-causal we use this idea, means either of two we have to select. We already discussed previously 4 type of pattern. ROC decide which pattern have Laplace transform out of 4 possible cases. Only we discussed 4 cases, slightly difference between one particular case have 2 inverse formula. Here then ROC will decide which Laplace transform related to which signal. Now we have some clarity about ROC and its transform. ROC is directly related to its transform. If ROC attached with this, signal is now specified or it should be valid in this region. Last case, if xs is, again I rewrite this expression, and now our ROC is in the range of minus 3 to minus 1. It means it is greater than minus 3 means greater condition is applied here, and less than minus 1 less condition is applied here. Minus t u of minus t xt. Actual difference between these two cases, if ROC is greater than minus 3, greater than means causal case, ut is attached with it. Less than a particular case means u of minus t is attached with this. We are not, now we are sure about inversion of this pattern. There are 3 possible way out to write inverse of this. Way out is depend on ROC only. ROC will decide which direction we have to move. In first case we write expression both are having in same domain ut. In second case we write expression both are in minus of ut minus in second case, because ROC is less than particular value minus 3. In case ROC is greater than particular value minus 1. In last case, it is in between. Is greater than something means we are following this pattern, and less than something we are following this pattern. Combination of these two, write the expression. And fourth one is not exist. Only three case exist with this transform. Convolution property is equally valid in Laplace transform also. Convolution of two signal multiplication in S domain.